All right, today we're going to take a trip 100 meters underground, right to the border of France and Switzerland, to check out one of the most ambitious projects humanity has ever dreamed up, CERN. It's this incredible place where they smash the tiniest particles in the universe to answer the absolute biggest questions we have. So let's head down and see what it's all about.
To really wrap your head around CERN, you have to start with its most famous creation. We're talking about a machine on a scale that is just, well, it's truly mind-boggling.
So let me just ask you this. What do you think is the biggest, most complicated machine we've ever built? A space station, maybe? One of those gigantic cargo ships? Well, the answer is actually buried deep underground, and it's a particle accelerator.
Get this, it's a ring that's 27 kilometers around. I mean, that's big enough to wrap around a small city. This thing isn't just big for the sake of being big. It's a monumental feat of global teamwork. And this entire machine, this whole massive ring, is tucked away in a circular tunnel 100 meters below the surface. And it actually crosses the border between France and Switzerland without even needing a passport. And this is it, the Large Hadron Collider, or the LHC for short. Its purpose is just breathtaking. It's trying to recreate the conditions that existed just fractions of a second after the Big Bang. The precision required is almost impossible to imagine. The scientists there have this great analogy. It's like firing two needles from opposite sides of the Atlantic and getting them to collide right in the middle of the ocean. It's this level of engineering that let them, back in 2012, finally find the Higgs boson, that super important particle that gives mass to everything else in the universe. Oh, and as a fun little side project, they've even managed to do some modern-day alchemy, briefly turning lead into gold.
But, to build something this grand, you need a motivation that's just as powerful. The LHC wasn't just built for science. Its story actually begins with a vision to heal a broken continent. So picture Europe right after World War II. The continent is rebuilding, and out of the rubble comes this pretty radical idea. In 1952, 11 governments get together, and by 1954, you've got 12 founding nations signing on to build a shared laboratory for science. And they decided to put it, very deliberately, right on the border of France and Switzerland, a really powerful symbol of unity.
And this was the principle at its very core. From day one, CERN's mission was all about radical openness. The founding charter literally required that all discoveries, all data, be published and made available to everyone in the world. This wasn't science for just one nation, it was science for all of humanity. And honestly, that spirit is what still fuels CERN today.
Now, a machine like the LHC doesn't just pop into existence, right? It's really standing on the shoulders of giants. A whole series of earlier, smaller, but totally crucial accelerators that paved the way for it.
You can kind of think of it like climbing a ladder of discovery, where each new accelerator was a step up. The whole journey kicked off back in the 50s with machines that helped us understand basic particles. Then came more powerful ones that revealed something called neutral currents, a huge discovery that connected two of the universe's fundamental forces. That success led to the superproton synchrotron, which found the famous W and Z bosons. Each machine was a vital stepping stone, building up the knowledge and the tech needed for the LHC to make its huge leap in 2009.
And of course, breakthroughs like these, they definitely get noticed. That W and Z boson discovery nabbed a Nobel Prize in 1984. Then, in 92, Georges Charpak was recognized for inventing a game-changing new kind of particle detector. And in 2013, the Nobel went to François Englert and Peter Higgs, the theorists whose decades-old idea was finally proven true by that incredible machine, the LHC.
But here's the crazy part. Maybe the most world-changing innovation to ever come out of CERN had absolutely nothing to do with smashing atoms. No, it was actually a kind of accidental solution to a data problem.
The problem itself was actually pretty simple. By 1989, you had thousands of scientists collaborating at CERN from all over the world, and they were really struggling to share their findings with each other efficiently. So a British computer scientist there, a guy named Tim Berners-Lee, he came up with a little proposal to fix it, a system of linked documents. He decided to call it the World Wide Web.
But what happened next is what really changed everything. Staying true to that founding mission of openness, on April 30th, 1993, CERN released the technology for the web into the public domain. It was a gift to the entire world, no patents, no licensing fees, nothing. With that one single act of generosity, they basically handed all of us the keys to the modern digital age.
So, from the Higgs boson to the World Wide Web, CERN's legacy is just immense. But you didn't think they were finished, did you? Oh no, they are far from it. They're already planning their next giant leap into the unknown.
And if you think the LHC is big, you have got to see what's on the drawing board next. They're calling it the Future Circular Collider, or FCC. The plan is for a new tunnel, 91 kilometers in circumference, that's almost 4 times bigger than the LHC, and it's designed to smash particles with an energy of 100 tera electron volts. That's more than 7 times the power of what we have now.
And the questions they want to answer with this beast are some of the deepest in all of science. What exactly is the dark matter and dark energy that makes up 95% of our universe? Could there be extra dimensions out there, hidden from us? Is there an entire new layer of physics beyond what we currently understand? We'll have an idea if this incredible project is moving forward by 2028.
When you step back and think about it, CERN started as a symbol of peace. It became an engine of discovery. It accidentally invented the modern internet, and it gave us a peek at the birth of the entire universe. All of that just leaves you with one huge, tantalizing question. If that's what they did in their first 70 years, what on earth are they going to unlock in the next 70?